Quantum non-locality is rooted in incorrect interpretations of quantum mechanics and incorrect mental picture of quantum phenomena. For example, quantum non-locality. Widely separated particles influence one another instantaneously. Correlations are coming out of space-time. An electron is indeed both here and a meter to the right of here. Impossible. Quantum non-locality is a misleading notion. In EPR-Bohm experiment, one photon is sent to Alice and its entangled partner to Bob. Alice and Bob measure spin projection of the photons, and the results are clicks on the detectors coded by ±1, ±1. Random outcomes are perfectly correlated or anti-correlated for some settings. Quantum non-locality implies quantum magic, a pair of dice showing always perfectly correlated outcomes. Fortunately, EPR-Bohm experiments do not exist. In Bell tests, we have no photon pairs which we are following. We have signals which are sent to Alice and Bob. Alice and Bob choose XY setting of the polarization beam splitter detector modules and obtain two spin time series of imperfectly correlated clicks registered in synchronized time windows. The results are coded by 0 ±1. 0 denotes the absence of a click. Why distant correlations? They may be due to a common cause or accidental. Two models with common cause. Bertelmann-Sox model proposed by Bell. Harry sends one sock to Alice and another to Bob. Their observations are perfectly anti-correlated. A dice model. Harry sends one dice to Alice and another to Bob. Imperfect correlation may be created. In analytical form, P lambda 1, P lambda 2 describes the ensemble of socks. In a closer horn pair of dice model, P lambda 1, P lambda 2 describes ensemble of dice. All experimental settings XY are described using a unique probability space lambda. Correlations obey Bell inequalities, which are violated by experimental data in Bell tests and by quantum projections. In quantum mechanics, the measuring instruments are not passive selectors of pre-existing properties. A detailed description of the measurement process going beyond quantum description must include a supplementary parameters describing the instruments. The choice of the setting is not the choice of the label. It is a choice of two probability spaces, lambda x and lambda y, of the parameter describing the instruments. Lambda 1, lambda 2 describe correlated signals. Lambda x, lambda y describe PBSD modules. Click or no click are produced in locally causal way in this and coded 0 ±1. Setting dependent expectation values are defined on specific probability spaces and Bell inequalities may not be derived. We have contextual description. Each incompatible experimental setting is described using a specific probability space, which is, and intersection of the spaces is empty set. Locally causal and textual graph, we have experimenters' freedom of choice. X and Y are freely chosen by experimenters. Lambda 1, lambda 2 parameters describes the signals, and the outcomes AX, BY I obtained in function of them. We have free will and freedom of choice. In our model, P conditional probability Pxy lambda is equal 1, what means if lambda x and lambda y, then settings xy had been chosen. Detailed proof you can find in this article. Superdeterminism and retrocausation are not needed to explain the correlations. Quantum non-locality and quantum magic are misleading notions which have to be abandoned. Lessons for QI community. State vector is not an attribute of a qubit. Unperformed experiments have no results. Quantum non-local correlations can be explained in a local causal way. Some references, papers of my papers, Krennikov's paper, Griffith's paper, Neuwenheil's paper, Deraut, Michels, and many authors share my point of view. Thank you.